Once you substitute the values, you get your answer here. And then now you can interpret that as either positive or negative, and whether weak or strong. And then again, you can retreat back to your values here. Then you can say, you can point out the direction, whether as one variable increase, does the other increase, or does it decrease? So any question up to that point? Okay, so we can continue. So that is one of the correlation coefficients. Yes, Gideon?
Squared.
Yes.
The total, is it 63.776?
Okay, what are you getting? The total for x squared. Yes?
The total of x squared. Is it a decimal point 63.776?
Yes, it is. Yeah. Oh, yeah. Oh, this comma. Yes, it is 63,000. No,
Okay.
that is way too high. So I think I did this again in a hurry. So okay, I'm going to send you this data again so that you can do and see whether you get the values that you get for this. I think I did that again in a hurry, so you're going to confirm. But now the process here is what is important. The values that you get here, make sure that they are correct for each one of them. Then once you do that, now you substitute and get the value of R. So I will confirm that again and see what value exactly is here. So I don't have the checks for this because I'm doing this so I don't know how. Yeah, so just make sure that I'm going to share this data again so that you can confirm the values. So that
It's
is
correct.
It is correct.
Though low.
Iko?
It's 63.82.
6382.
Yes.
Okay. So that is 63,000.
820.
Okay. Yeah. So I think I did that. Add that again by hand. I didn't use I used a calculator, right? But possibly I missed a letter or a value. So you are going to confirm for the values, then you can get what is the value of R. Then you can now interpret now in terms of the correlation, whether it is positive or negative, and whether there is an increase that causes an increase, or there is an increase that causes a decrease, and so on. Now, for this formula, still you can try to use this formula, but for this one, for now, let's concentrate on this formula of R. So the only thing that sometimes students miss the N here. So you have to be careful about. Yes, Maina?
Excuse me, sir.
Yes.
You remember down there where we were putting the digits? You removed 10.
Or here.
Uh,
So yeah, this is what I said, that this 10 is supposed to be, it is a multiplier of this 24, 30, 36.
oh, yes.
Yeah. So I said that this has been misplaced. It is supposed to be inside this. You see the square bracket. You can see there are square brackets here. So this 10 is supposed to be inside this square bracket, multiplying this 24, 30, 36, just like we have it here. Here, you can see n, then summation of y squared. Yes, Shine?
Mwalimu, where
Where?
the formula?
Yes, come up again.
In the formula
Mm-hmm.
in which we multiply by the values of x. So I see we have 10 and n. Imetoka wapi?
Yes, that's what I'm saying. 10. Remember I said in the previous class, n is always the number of values. Now, n can also be said to be the sample size. Actually, in statistics, n we refer to it as the sample size. The size that you've taken. So I said that here we have 10 people, because I said we have 1, 2, 3, or the 10. There are 10 of them. And for each one of them, we are recording their weight and blood pressure. So if it is you, Shine, I'll record your weight and also record your pressure. Then I go to minor, I record their weight. Okay, these are not exactly your weights. It could be not true, or it could be true, I don't know. But so I'm doing this for each one of you. Then, this part here now, okay, this again is an error here. This is supposed to be 82. 82. I hope I captured that right. So yes, 82. You can see here on this X, it is 82. So again, that is a typo. It is a typo. So, but I think I took care of that here. So this is supposed to be 82. So I will send the exact data that for this. So the N is the number of items, the number of persons, the sample size, and that is 10. So 10 individuals. You recorded for each one of them, you record their weight and their blood pressure. So that is the 10 that now I'm bringing down here. Here. So we can see we have n summation of x, y. So n, which is 10, then summation of x, y, it's down here, 124, 20, 69. Again, you can see I have also omitted the 9. So I don't know how I did this. And I'm always sober, but this time around, I don't know what I had used. So, but this is supposed to be 124, 20, 69. Then we have, again, summation of x here, multiplied by the summation of y here. That is okay. Then here we have n multiplied by the summation. So you can see this 10 is only multiplying this 63, 7. So you said it is 63, 8, 20. So it's only multiplying this part here. Only this. So you only have that 10 times this value. Just like in the formula here. You only have this. This cannot easily highlight because it is mathematics. So it's a formula. So n multiplied by the summation of x squared. Just that. This part is alone. Summation of x, it is only alone, then squared. Then you have the brackets. So what I want you to be careful about is the brackets. Why you put these brackets? Because if you happen to just have them open, then you might multiply the wrong things. So you need to just watch about that. Now that is, I was saying that is one example of the correlation coefficient that we refer to as the Pearson's product moment correlation coefficient. Then you have another type of correlation coefficient that we do refer to as, so you can see now this Zoom is not allowing me to write anything here, but if it were the Connect, it would be possible to write easily. So we have another type of correlation coefficient. We refer to it as the Spearman rank correlation coefficient. So now this one uses ranks. So we have we arrange it in ascending order. So if I take you back a little bit to the time you were possibly in high school or in primary school.
What do you mean, Spearman?
Yes, Spearman. That is just the name of a person called Spearman. So we have Spearman rank correlation coefficient. So here we rank. So I was saying, if I take you back a bit, when back in high school or in primary school, you used to be ranked from position 1 to the last person. So what happened is that the first person, the person taking the first position, was the person with the highest marks or the highest grade. So the highest grade again translates to highest marks. So that would take the first position. But the last person was the person with the lowest marks. And so you're going to rank them 1, 2, 3 as the marks decrease. Okay. So the first rank is the highest rank, the person with the highest marks, and so on. Then we have a formula for this. Again, a simple formula. We denote this by capital R, and we say R is equals to 1 minus, then we have a fraction here, 6, summation of D squared divided by N into N squared minus 1. So I hope you can see that, and you've written it down. So this is the Spearman rank difference correlation coefficient. So this is the formula. So here we already know what is N, but now we want to know what is D, then the D squared. So we have an example. So in mathematics, it's always good to use examples so that it is easy to demonstrate whatever you're doing. So we are saying for a person, for this, you have a record of grade point average. We say that it takes X, and graduate record exam score. So you have subjects. So subject would be people, students, could be anything. So we are saying we have, again, 10 people, 10 subjects that we are considering. So we are recording their grade point average, the grade point average. So for the first one is 8.3. Then we record their exam score, 2300. So we are taking X to be our grade point and Y to be our exam score. So we record for the 10 people. Now, for each of these variables, so now we now move from the points and the exam scores. Now we talk of X and Y. So X and Y, we want to rank all these values of X. We again rank all these values of Y. So it means we are going to start rank number 1 for X will be the highest point. And the highest point is what? In this case, for X?
9.8.
Yeah, 9.8. So that will take rank number 1. Then when it comes to Y, rank number 1 will be taken by? Yes? The highest value in Y is
2,400.
Yeah, exactly. So now there are things that we again need to consider for the ties. Remember how they used to rank people who have a tie. So if you have position 2 and 3, then if they are a tie, then it means the next person you are going to consider, they will be number 4. They're going to be number 4. Now, what happens now when it comes to these statistics? Say, for example, as we rank them, here, let's just see how we rank this. So these are how we rank them. You can see this table here. So you have X and Y. So I have not altered how they are distributed. So the first person here is 8.3, 8.6, all the way to 8.6. So that is the same way I've done this. So 8.3, 8.6. So I've not altered how they appear. Again, for Y, I've not altered. The first one is 2300 all the way to 2260. So again, I've not altered that, 2300, then 2260. But now, when it comes to the rank here, so you have the rank of X, you have the rank of Y. We start with the rank of X. So we are saying the first one was 9.8. So 9.8, we give it rank number 1. So the next one, you can see the next one from 9.8 is 9.4. So we give it rank number 2. The next one is 9.2. We give it rank number 3. The next one is 9.0. Here, we give it rank number 4. From 9.0, we go to 8.6. So we have 8.6. So you have this one here, subject 2, 8.6. Then you have subject 10, 8.6. So what do you do? So we are saying that one of them could be number 5, the other one number 6. But since it is a tie, so we move up here. Since this in X, for instance, 8.6 occupy ranks 5 and 6. So each has a rank of, so you take 5 plus 6 divided by 2. That's how you get 5.5. 5.5. Then, since we have the two ties, so the next rank will now be rank number 7. You can see we don't have a 6. Don't have a 6 in this. So once you have a tie, we move to the next value. That is 7 now. So 8.3, then 8.0 takes rank 8. Then you have 7.8 taking rank 9. And then you have 7.2, the least or the lowest, taking rank number 10. Then again, you do the same to Y. The first one is 2400. So that becomes rank 1. So this could be just a mere coincidence that subject number 4, 9.8 is rank 1, and for Y and for X. So it could just be a mere coincidence. It doesn't always happen that way. So rank number 2 for Y is 2380. You can see this. Rank number 3, 2360. Rank number 4, 2350. Rank number 5, 2300. Rank number 6, 2260. Then rank number 7, 2250. You can see it here. Rank number 8, you have 2100. Then we go to the next one is 2000. So 2000 is the least. And so there are 2 of them. So one of them was supposed to be rank number 9, then the other one rank number 10. But since it is a tie, so you take 9 plus 10, you divide by 2, you get 9.5. So you rank both of them, 9.5, 9.5. Then what is D? So here, this is what we are interested with, because this is what is applying to our formula. So D means the difference between the two ranks. So you're taking 7 minus 5, you get 2. 5.5 minus 7, you get negative 1.5. You're taking 3 minus 2, you get 1. All the way down up to 5.5 minus 6, you get negative 0.5. Then you square your D. So 2 squared is 4, negative 1.5 squared. So the negative is also inside the bracket as you square, so you get a positive 2.25 all the way down. Then now you can substitute that into the formula. So you get the sum. So you sum all these. Again, confirm whether that will give you 12. So summation of D squared is 12. We have n sample size. Our subjects are 10. Then you substitute that into the formula. So 1 minus 6. The summation of D squared is 12. So it's multiplied by 12. Then 10 into 10 squared minus 1. So that will give you 1 minus 0.027. I mean 0.0727, and that is 0.9273. And you can see again that this is positive. It is almost close to 1. So it means it is a strong correlation. It is a strong, so this value here, it is a strong positive correlation. Strong positive correlation. So what does that mean? It means, so as X increases, Y increases. But what is X? What is Y? What is X? What is Y? You retreat back here and you say, this is the grade point average. And then Y is a graduate record of the exam score. And you say, as the grade point average increase, then the graduate exam score also increases. So I hope this is again very clear. It is straightforward. So you just need to know and understand this formula and how you rank this. And then you get this, you rank them, then you substitute the values into the formula and you get an answer. Then you can interpret this. So any question up to that point? Any question? Yes, Gideon?
The disk says it's equals to 12. Does it come from the summation of the D squared?
Yes. So here we are only working, you see our formula requires us to have D squared. So summation, you sum D squared. So all the values you've gotten for the D squared, so in this column. So once you sum this column, it's supposed to give you the summation of D squared, and that is 12. So again, I don't know whether that is actually the correct value.
Yes.
Yeah.
Yes, it is.
Okay. Yeah. So that's how you get the D squared. So you and now these remember here we are only interested with the mostly the application, and like we said, for the first one was on the weight and the blood pressure. So that is something that you can do. Again, something else you can do, possibly your score and the number of hours possibly that you study. So there are some people now, and in most cases, this is what happens. The more hours you take to study, the higher the chances that you are going to score a good grade or high marks. If you don't study, if you don't do practice, if you don't take a lot of time possibly doing the practice in this, then you are likely to score very low. So I think the many years you've been to school, you can be a witness of that. Yes, Gideon.
Wanted to.
Yes.
So when we are ranking them, you say kama ni 22,250, the next number should be, we take 6. So we took 6 plus 5 divided by 2. Are we assuming since its should be 5, we just put it 5.5? Or can we get a number that when we divide by 2, it will 5.2 or 5.3, 5.5 or 6.5?
Yes, you see now, okay, it's only that that our tie is in, you see, in the in the Y, our tie is for the number that was supposed to be rank number 9 and rank number 10. So if you add 9 plus 10, you're going to get 19. Once you divide that by 2, you get 9.5. So we are saying we can have the first, you can have the first two values, the first highest values, you can find a tie, 1 and 2. And so one will take 1, you have 1 plus 2, that will be 3. Then you divide by 2. That will give you what? That will give you 1.5. So you find that the first rank is 1.5, the second is 1.5. Then from there, you move to 3. So the next one will be rank number 3. Okay. So now, for a case where you have 3 values which have a tie. Okay, Gideon. So at such a point,
yes.
Now you're going to divide by 3. Okay. You're going to add them, then divide by 3. Then you're going to allocate each one of them whatever value that you get. Then from there, straight away, you move now. You're going now to move 2 steps ahead, 2 steps forward. Okay. So if there is a tie for 3 people, and that is say 4, 5, and 6. So once you add them, once you add 4, 5, and 6, then you get, in that case, you're going to get what? You're going to get 15. Then you divide that by 3. So you're going to get, that will be 5. Is it 4, 5, 6? Yeah, that will be 5. So the first, that means you're going to move now 2 steps ahead of this. So the next person will be rank number 7. But in most cases, the data that we collect, you are likely to find that there is a very small difference. For this one, we are only considering up to 1 decimal places. 1 decimal places. So if possibly we did to 2 decimal places, possibly we could have 8.62 and the other one 8.65. So you can see those will be different. Those will be different. But in most cases, what we are we'll find is a tie of only two values, mostly. Only two values, because again, if you find that you have a tie of so many values, then it means that data will be what we refer now to as skewness. It will be skewed towards a certain direction. And that is not going to give us a good statistics. Okay. So you might find those, you're saying it's not easy to, it's not always that you can find possibly the with that 0.3, 0.7 point, not always that you can easily find some of those values. Again, we are not using a so large data. We are not going up to hundreds and so on. We're just selecting a very small sample, and that sample is going to represent a very wide set of data. Now, again, the Zoom is about to go off. But we can check this. So this is called regression. So this is the what I was explaining. So very fast, move down here, regression equation. We talk of y is equals to a plus bx. So remember I talked about y is equals to mx plus c. So this is what we are used to. Y is equals to mx plus c. But when it comes to statistics, we change this a bit. So where you had m, we now have b. Where you had c, we now have a. So the interest for this regression equation is to be able to predict some values given values of another variable. Say like the way we had the blood pressure and the weight. So can we use some of the values of weight to predict the values of the blood pressure? So for a person who possibly weighs 70 kg, using that data, and now applying this equation, we can be able to get what is their blood pressure. You can predict, or we can estimate. So before getting this equation, you need to get the values of B and the values of A. And here is the formula for B. So you start with B, reason because when it comes to A, you again need to use that B in your formula for A. So you can see this almost looks almost similar to the other one for the correlation, but they are not the same. You can easily compare the two and you can tell that there is a difference between the two. Now, say for example, you have this set of data, the midterm exam and the final exam. So what happens is that we can use the midterm score to predict your final score. You can use the midterm to predict your final score. Or we can move backwards. When you have your final score, we can try to predict what could have been your midterm score, and so on. But this is not what we do. We always record your marks. Whatever you score in the cut, we record. Whatever you score in the final, we record. We do not do this prediction. So if you have missing cut marks, we don't go backwards to predict what you could have scored. Okay. So so can we be able to predict that? So we put our midterm to be X and our final to be Y. And again, we come up with a table almost similar to the previous one for correlation. But here you can see we do not have the values of Y squared. They are not here. The values of Y squared. Reason being, we do not need the values of Y squared in our formula for B or for A. We do not need values of Y squared, and that's why they are not included here. Okay, they're not included. But we may find that this is one question, a whole one question requiring you to get the correlation and requiring you to get this regression line. So once you do this again, the totals, so this one I need not to repeat so much.